Where is it?
Yeah.
Here. You should be able to see my screen right now.
Right. Yeah, we're able to see your screen right now. Just
all right. So
please take someone away.
All right. So hi everybody. Thanks for joining us today. My name is Davide. I'm the DevOps and Infra lead at PlayStudios currently here in Hong Kong. I'm a former DevOps architect, and I used to work before for Microsoft first in the Azure DevOps engineering, and then in the GitHub engineering, working obviously on GitHub and working with our clients. And I'm also a former MMA fighter. It is something I normally say, especially in in-person events, because usually there is a evaluation form. And I always say, remember that I'm an MMA fighter when you fill in the evaluation form.
It's really cool.
Thank you. Yeah, feel free to reach out to me to any of the contact means you see on the slide there. I have Twitter, GitHub, LinkedIn, or I have a website. And I'm also a allegedly famous YouTuber. I have a YouTube channel called Coder Dave, where I cover 360 degrees around DevOps. I started obviously, especially with Azure DevOps and GitHub. I'm covering more and more on different topics like Kubernetes and whatever it fits the DevOps umbrella. I cover those things. All right, should I start? Do you want to say anything else?
Actually, I want to say something before you do, but you already have introduced yourself, and it's just like so cool. Like MMA fighter. I mean, what it was. Let's bring back to the professional side. Yeah. He has worked in Microsoft at GitHub and is a DevOps architect, and he worked in more than 18 years of experience. And yeah, so today he's going to show us what are the free things that we can do to protect our open source project for free.
Yeah.
Yep. So it's up to you, Davide, right?
Thank you.
Thank you.
All right. So I think we can all agree that security is important in every aspect, but especially when we talk about software, right? And there is this kind of practice that it's likely taking more and more popularity within the software delivery chain, which is doing continuous security, which basically means having security embedded in basically any phase of your software development journey or the software life cycle. In this slide, you can see only a few of those moments marked with the red arrows in which you can apply security before development and during development, during testing and after deployment, which those are only a subset of the actual continuous security, because in my opinion, continuous security means that you should secure everything from when you start until when you finish, which basically means never, because you never finish, right? But this is in clear contrast with what we used to do before, which was doing security or doing security hardening and security scanning on our software just right after deployment, right? And in this motion that we call shift left, we need to have tools and practices to cover basically the application of security throughout our development lifecycle. And today I want to talk about two main tools that allows us to shift left and for security, and allows us to do it very easily, as you will see later in the demo, but also completely for free. As I mentioned before, I used to work for GitHub, but I don't work for GitHub anymore. I don't work for Datree. Those are just tools that I happen to use and love, and I think they have a great value for users. And most of the things in the GitHub Advanced Security are open source, and Datree itself is open source. So what those two tools do is GitHub Advanced Security allows you to have tools again in your pipeline to secure your code, making sure that you don't have secrets in your code, and making sure that all your software all your dependencies are not vulnerable and are managed correctly. And what Datree does is taking this and also extending it to Kubernetes. We know that when we work with Kubernetes, we have a lot of different ways to do so. We have a lot of files. We can use kubectl commands. We can use Helm charts. We can use Argo CD and other stuff like that. And it's fairly hard to try and secure that before deploying the application. There's a lot of tools that do scanning of your Kubernetes clusters or your deployments in Kubernetes. But then, of course, it requires the application to be deployed. But as I mentioned before, we want this shift left motion. So we want to do this before deploying and ideally as soon as possible. And Datree does that, allowing you to automate your policy scanning and applying best practices to your Kubernetes manifests. So those are the two tools I'll talk about today. And with the context here is the open source development. Those two tools are free. Especially GitHub Advanced Security is free for open source and for public repositories, as we will see in a second. It's not the same case for private repositories, or if you are in GitHub Enterprise Cloud. In that case, the tool is a paid tool. How those two tools fit in our development life cycle? Well, for advanced security is mostly during development. You can do code scanning, secret scanning, etc. during development phase. For Datree, actually, it spans, I think, a bigger landscape, if you will, because you normally would use that still in the development phase, but you can integrate that also in the testing phase and also in the deployment phase as well. So to have like a continuous scanning of your Kubernetes manifests. Let me spend a few words with GitHub Advanced Security, and then we will have some demo. So GitHub Advanced Security is a fairly complex suite of tools, but for the scope of this presentation, I will focus on three different flavors, if you will, of advanced security. One is the code scanning, which is probably the most known. Even though a lot of people think that this is a paid feature, it is actually not. As I mentioned before, it's free for public repos. And what it does is using CodeQL, which has been inherited from GitHub, using the acquisition they made on SAML and Look Good to Me, GTM. They integrated the CodeQL, which is basically the industry-leading query language for code analysis, and integrated into GitHub. And now you have this amazing feature that allows you to analyze the code in your GitHub repo and find not only known vulnerabilities, but also coding practices issues and coding malpractices, if you will. And this, of course, is integrated into GitHub, so you don't have to do anything you don't have to purchase anything or anything like that. And it's also interoperable with third-party scanning tools. Like if you're using other, Sonar Cloud or whatever else you're using, as long as they output some SARIF file, the static analysis results interchange format, which is basically a de facto standard for code analysis. As long as your tool output that SARIF file, then you can grab that, integrate it into GitHub, and having a single pane of glass for seeing all your security-related information. The second flavor I want to talk about today is the secret scanning. As the name says, is a tool that scans your repo for secrets, but it doesn't do only on the current version of the code. It also scans the entire Git history. And it is very important because, as you probably know, there are ways to rewrite the Git history, but it's not that straightforward. And even if you commit a secret to your repo today and then you discover it and tomorrow you remove it, you commit another 5 without the secret, but then your secret is actually present still in your history. So secret scanning goes on and scans the whole history in all your branches for the repo in which it's running. And again, it scans for passwords, secrets, the tokens, API keys, and whatnot. And the very, very cool thing, and we'll see an example of this in the demo, is that this works with, and there's a typo in the slide I just noticed, this works with more than 150 service providers and cloud providers of all kinds. And what it does is it's able to recognize your secrets and API keys, for example, based on patterns that these third-party service providers give to GitHub. And if anything like that is automated, GitHub, found, GitHub will send a notification to the service provider and say, okay, we have found this API key in this repo. What do you want to do, basically? And those service provider have the ability to automatically disable or rotate those keys for you. So even if you commit that to your public repo and you haven't noticed, if someone try and go get that key, will not be able to use it because the service provider has already disabled it. And this is a very, very cool thing in terms of security features that this provides. And last but not least is all the dependency management. This is probably the most known feature of advanced security of the GitHub security suite, because we talk about like Dependabot and dependency vulnerability scanning and issues. And again, what this does is not only scanning your projects for finding if your dependencies are vulnerable. And when we talk about dependencies, we talk about, npm packages, Python packages, all the dependencies like NuGet packages, all the dependencies that you can import in your project and use that like third-party dependencies. As I was saying, this not only scans for that and send you alerts. Obviously, you need to be alerted if anything is wrong or any vulnerability is affecting your repo, but also if you enable it, it can create automatically the pull request for you to upgrade your dependencies in your project to a non-vulnerable version. And you can even take a step forward and ask Dependabot to create pull requests to update your dependencies, even if they are not vulnerable, but you're running behind on the versioning, right? Let's say I'm using version 3 of a given dependency, and the publisher just published the version 4. I can ask Dependabot to do the upgrade automatically for me, if obviously there's no conflict with other dependencies, because the last thing you want is fixing something but breaking 10 other things. So Dependabot is smart enough to understand that they cannot upgrade that given dependency if the other dependencies have version requirement, for example, or stuff like that. And as I was saying, this is 100% free for public repos, for open source projects. And there are features that if you are on, for example, GitHub Enterprise Cloud, you can buy separately and extend this functionality. For example, you can have custom patterns in secret scanning or stuff like that. But for what I just mentioned, and we will see that in the demo, this is 100% free. I just want to talk a little bit more about code scanning because I think it's important. As I mentioned before, it supports CodeQL, and it supports both compiled and interpreted languages. You see the list on screen. I'm not going to go through that. That new languages are added on regular basis. And my experience with the list, I've been using it for a couple of years already, even when it was in preview. And I've always found that it has a fairly low false positive ratio. One of the main problems you have with most of the code analysis tools is that they generally can give a lot of false positive. And that's a problem because if you have a ton of alerts and most of them are false positives, then it's really hard to go and see what is actually a problem and what is not. And then on the long run, you start not using those. And also, I've seen that in some cases, and I have an example later, it can catch issues that other tools couldn't or wouldn't. And it's a big advantage in my opinion. And of course, it's fully customizable, it's configurable, it's based on some rules that are predefined if you want to use them, and those are the default ones, but you can write your own queries, your own rules. You can publish them in packages or in whatever you want, however you want, and you can also make them available to the broader community, if you will, in an open source spirit. All right, let me quickly talk about Datree as well, and then we go into the demo. As I was saying before, Datree is a tool that allows you to scan your Kubernetes manifests and Kubernetes deployment files, for example. And at its base, why we want to use it is because we want to prevent misconfigurations to reach production or to reach whatever deployment you're going to do. And Datree does exactly that. It scans your file and is able to enforce policies and Kubernetes best practices based of a huge list and also configurable as well. And it can do so right now for kubectl manifest, Helm charts, and Argo CD, and more formats are added and will be added over time. And not only can scan your schemas and do policy check, for example, but it also adds some sort of linting because it does YAML validation, so you're sure that you haven't written a wrong YAML even before trying to push it to your cluster, and which is a huge thing. Having a tool that does all of this together, and also does schema validation. This is especially important if you have different clusters on different cloud providers, for example, or with different versions of Kubernetes, because some features are version dependent. So maybe you're running your cluster on Kubernetes 1.19 on one side, and then you have another cluster on Kubernetes 1.22, which have quite a big difference in terms of APIs that you can use. And if you try to use the manifest for the 1.19 on the 1.22, I think everything should work. But if you try to use a manifest for 1.22 in Kubernetes 1.19, there's quite a few things that won't work. So you may encounter that. If you want to make sure that all your manifests are working across your spectrum, you can use the schema validation of Datree. And again, we will see that in a second. And again, this is 100% free. Until a couple of months ago, you had a limit on the free version on how many scans you were allowed to do each month. And I think it was like 1,000. But now they removed that, and it's totally free. It's open source. You can go to github.com/Datree, I believe, and you have all the code there to check and whatnot. So again, I think is a great tool. With all of this said, let's see this in action. So let me open this. So I have this Newton/HKOSCon 2022. Newton is my handle in GitHub. And I created this repo to showcase, the tools we are talking about. So I have here a Node.js application. I have a .NET Core application. I have some Kubernetes files in here as well. I want to start with, let's start with this one. So as you can see, this is probably, again, one of the most known features of the tools I'm talking about, and it's Dependabot in action. So Dependabot, as soon as I pushed my code to the repo, automatically scans the repo, and I had to enable it in the security tab. And in here, it has identified some vulnerabilities. So I can go and check. And again, in the security tab, you have these dependable alerts. And in here, you see I have 29 different vulnerabilities in my dependencies, and it can be high level, low, critical, and whatnot. And if I try to open any one of those, you have a comprehensive list of what the problem is and why the problem is rated whatever it's rated. You have on the right here a lot of base metrics for CVSS on on the vulnerability itself, and all the information you need. And now you also know that I'm running, I think I'm running version 2.6.1 here. And they also say that I can install 2.7.4, but because I have these dependencies, so this is what I was saying before, that Dependabot knows that, for example, this other package requires this version here, and therefore, even though it can go to this version or to 3.1.7, which is the first one with the patch, as you can see here, it doesn't do it automatically because I would need to upgrade the other dependencies as well. But if we go back to this one, as you can see, I have the pull request icon over here. You can see that Dependabot again, it gives me, in this case, way more information than before. This depends on the security bulletin that the vulnerability maintainer decided to publish. In this case, is more complete. But not only, you can see that Dependabot was able to automatically create a pull request for me, and I can review it and decide if I want to, update or not. In this case, it should be fairly easy. Just updating the version of Electron and in my package.json. And again, in this case, I only have one pull request. I use some code that I haven't updated in a while, so a lot of my dependencies are fairly old, and therefore Dependabot has a lot of trouble in trying to update all of dependencies. Also because I haven't enabled, if I go to the settings, I haven't enabled in this repo the Dependabot version updates. This is what I was talking about before. So I enabled the security updates, which means that Dependabots can try and open pull requests for me in case my dependencies are deemed vulnerable, but will not do so for dependencies that are not deemed vulnerable. If I enable this, I should be able to see, we can try live. It will, well, no, I don't try live because I don't want to kick off the CI right now. But you should be able to see that all of those security vulnerabilities, or maybe the majority of them, could be solved because other vulnerabilities will be, other dependencies will be upgraded, and therefore the vulnerable one can be upgraded as well. All right, so this was for the vulnerabilities. And again, even if you don't have the pull request directly created from Dependabot, it's really easy to see, what's wrong and why it's wrong and what version you should use, and then, work your way back in upgrading the other dependencies if you want to, and you probably want to. Another thing we probably have seen in here is these code scanning alerts. Now, if I go here, you can see I have 6 different code, vulnerabilities. Some are related to JavaScripts, like you can see here. Some are related to code. So what I want to do right now is show you how all of these work. And first of all, how do I know that I have these vulnerabilities? Well, I know this because, again, when I went to the security tab, let me try and do this in how to move this thing. I have the bar. All right. Let me try and show you this in a repo that doesn't have that enabled, which is probably, yeah. For example, now in this repo, I don't have the code scanning alerts or the code scanning enabled. So if I click on security, you can see that I have this setup code scanning button over here. When I click on that, I can click on configure scanning tools. And what it does, it gives me the possibility to decide what I want to enable. Now, I can search for CodeQL, which is GitHub's default one, which is basically code scanning. And you can see that it automatically generates for me the YAML for GitHub Actions to kick these off. And it also says that it automatically attempted to detect the language I'm using in my repo. In this case, it's only YAML, so I'm not sure what it found out. And in fact, yeah, it wasn't able to detect any language because this repo is not a software repo, if you will, it's more a configuration repo. But this generates for me the whole thing I need. And in fact, if I go back to my example repo I was working on a second ago, you can see that I have again this CodeQL analysis YAML in GitHub Actions, and is exactly the same kind of structure. You have all your triggers, you have all your jobs, but in this case, it was able to automatically detect the languages I'm using in this repo, which again are C# and JavaScript, because you remember I have a .NET application or ASP.NET Core and a Java Node.js application. And what it also does is, apart from initializing the things it needs, but it also have this very cool task here that, let me make this a little bit bigger, that for compiled languages, it try and build your software without any interaction. So basically, if this works, you can just commit this file and you're done. This works very well for most of the builds, whether it's C or C# or Java, as long as you don't use some custom scripts or custom things in your build. Obviously, if you need to pass a lot of parameters to your build or custom parameters and custom components, then this auto build will not work. But in general, it does work pretty well. With this, you can see that I added configure for CI on both branches and main branch for pull request, and I also have it configured for like cron triggering, schedule triggering. So I want to have this monitored all the way through the life cycle of this repo, and you can see that this just goes and for each of the configured languages, like C# and JavaScript in this case, it kicks off the scan by itself, and you can see it's fairly quick. It took like 1 minute 43 seconds, including the build. For JavaScript, it's a little bit longer because there's a lot of files in that application. But of course, the auto build is 0 seconds because there's nothing to build for Node.js. It's just JavaScript. And at the end, what it does is, again, publishing here your alerts, like for example, this XML injection, which is not a vulnerability per se, right? There's no vulnerable component, but my code in this case is vulnerable to XML injection because of the way I concatenated those strings. And again, you have a full explanation on why this is a problem, how you may want to fix it, and they go all the way to even giving you a solution. So if you look at that, this is my code, and this is the solution that they propose to you. So this is not true for everything. There are instances in which they couldn't give you a solution, but I've found that in most of the cases, you have a workable solution that is proposed to you directly from code analysis. And if you go back for a second, this is also where, if you use another tool that integrate with Sarif, as I mentioned before, you can have your single pane of glass, as I said, to see all your alerts and vulnerabilities. What I want to do right now is, if I go back in this vulnerability, I can see that this is in this file in the home controller. So I want to go in here and fix it real quick. So controller, home controller, and my fix for the moment will just be, I'm doing this in directly in GitHub. I think you will probably want to do it in a proper IDE. But just let me just remove this. This is how you fix problems, right? You just comment the code out and everything is all right. And let's create a new branch for this. I'm creating a new branch because I want to show you how it works during a pull request. I'm not going to put in anything. This is obviously bad, not best practices. It's bad practices, but for the sake of the demo, I think it's all right. So as you can see now, I have CodeQL running for both JavaScript and C# as a status check for my pull request, and I also integrated some Sonar Cloud analysis for comparison. While this runs, remember that in here, I had, apart from this XML injection that I just quote unquote fixed, I also had all these others vulnerabilities, which are deemed fairly high, and some medium stuff. So I want you to keep this in mind when we'll see the results on this pull request, because it's something that, as I was saying before, I think code scanning does fairly well. Other tools may not be as accurate, if you will. So this is still running. It will take just a minute. And while we wait for that.
While we wait, we have, just a reminder, we have 1 minute or 2 minutes to go. Yep.
Okay. So let me quickly show you about the other tool, which is Datree. So the way you use Datree is, again, as you've seen on these, I only had a couple of files. So I have this Kubernetes directory inside my repo, and I have two manifests, service and deployment. So what I can do is calling Datree test, for example, service YAML, and in just a second you will see that the scan is performed. And I'm not sure why is this slow. Usually it takes way less time. Okay. And what it's doing now is connecting to this centralized policy control of the tree, in which I have 17 rules, and you can see that all 17s are passed. But if I use the other one, and again, this will take just a few seconds, you can see that 4 have failed, and I have here the whole list of, I didn't configure CPU limit, I haven't configured CPU request, and so on and so forth. And I can go to the Datree interface in the history, and you can see that I have exactly the same kind of output for my repo, and I can go and check in their documentation, how to fix all of these. Very last thing I was saying before, the CodeQL here as finished. You can see that regardless of the fact that we have other 5 or 6 vulnerabilities, Sonar Cloud didn't get anything. It says everything is all right, 0 bugs, 0 vulnerabilities, and this failed because of the other bugs. All right, sorry, I ran slightly out of time. Apologies for that, but I hope you appreciated the presentation.
Yeah, no problem. Thank you very much. It's very interesting to know that there are some inbuilt tools within GitHub that we can just click and use it, and it helps us to save some vulnerability. So right now we have a few questions.
Sure.
Yeah. So let me scroll back from Ivan. Can those two tools be integrated with Azure DevOps?
Well, the tree definitely you can run it. You can run it anyway. I had also an example here of it running in Actions, but the tree can be integrated with everything. You can run it manually. You can run it in Azure pipelines and stuff like that. Code analysis used to be you used to be able to integrate it in Azure DevOps, and I have a video on my channel about that. But they changed, and so now it's not possible to do that anymore. And for secret scanning and dependable, there is a way to make it work for Azure repos. And again, I have a video on my channel about that. But secret scanning, no, it's only for GitHub.
I see.
Yeah.
So if you want to know more, we should go and watch your channel, right?
Yeah, definitely. I do have quite a few videos about code scanning, advanced security, and other stuff like that.
Yeah, this is very cool things to get the pen test report self-serve. Yeah. And then you are easy to check in the GitHub to check any vulnerability for a project. Yeah, it's very cool tools. Because for such security DevOps tools are very expensive if you want to buy it.
Yeah, and again, for GitHub Advanced Security, if you want to use it in a corporate environment, still it's fairly expensive. But if you want to use it for your open source projects or public repos, it's completely for free. So it's
cool.
Provides a lot of value in my opinion.
So actually, I'm curious about the scanning. It's like if you scan it, how often do they scan it? Like daily basis, or what there's an update, or?
Well, for dependable and excuse me, for dependable and secret scanning, it's automatically done. As soon as you push your code or any changes to the repo, you get the dependable alerts and the secret scanning done. Right. If you for CodeQL instead, you can do your own, or for code scanning you can do your own schedule.
I see.
If I may, one thing I just remember I didn't mention is the secret scanning. So I did have a secret pushed in my repo. As you can see here, I had this SendGrid API key, and secret scanning does work. And in fact, I wanted to show you these, which is an email that I received as soon as I pushed that on my repo, that says that basically GitHub has notified Twilio or SendGrid for that, and they have temporarily suspended my account because of the API key posted in the repo, and I have all the information on how to remove it and how to do it.
Right. So thank you very much. And if you have more questions, actually we have a little bit of break time. So actually just turn on the mic. I mean, for our audience, you're welcome to just turn on the mic and talk to our speaker, David, here. And yep. And it is time also to remind you to fill up the survey form. Let me send, can our staff show our survey form QR code on the presentation screen? And it's break time until 4 o'clock. And next we'll have a SQL talk. So meanwhile, we can just do our casual talk here, chat here.